Alright, so in this problem we have a solenoid. So we're going to draw our solenoid here. And it's going to have a radius of 3 centimeters. And n is going to equal 400 turns. And it has a changing current that's represented by the function given here. And then we're given the length of the solenoid as 20 centimeters. And then we pass that solenoid through a loop, and that loop has a radius 4 centimeters. So you can see what I did up here. I started with our new version of Faraday's law because our goal here is to find the induced electric field. So this is the only way we have to find an induced electric field. And on this side, I plugged in my integration that I'm going to do. So we're integrating over the path of the loop. So that's the circumference of a circle, 2 pi r. And then on the other side, since the solenoid has the change in current or the change in magnetic flux, I first subbed in area. And remember, anytime we do Faraday's law, there's technically speaking supposed to be an n out front here. And then the magnetic field makes up the rest of that particular relationship, where the only difference for the magnetic field is we have a varying current, so we have a dI rather than a capital I, and then dt comes from the bottom part of Faraday's law up there. So over here I'm doing a substitution, so I'm plugging in 1 here because there's only one loop here. And then we're doing area, which would be pi r squared. So we're doing the area of the solenoid because that's where the magnetic field is coming from. Then we're doing the number of turns of the solenoid times our magnetic constant. And we're dividing by the length of the solenoid. I've then done the derivative of my current function, and that's going to replace the di dt. So we end up with 8t, which is derivative of 4t squared. Up here now, I have plugged in for the radius of the loop, which was 4 centimeters. And then I have plugged in for t, which is 0.5 seconds. This allows me to find the induced electric field at that particular moment in the loop.